Welcome to today's lesson on rules of exponents. So we've talked about in class this idea of exponents, how to use them, take square roots, take cube roots, and now we're going to talk about when we have exponents that are higher than those and how we can work them together. So I'm going to run through a PowerPoint that's the book provides and sort of explain a little bit here and there, and then we're going to use this idea to hopefully play a game slash activity which I think is fascinating. So let's go through this. All right, we've got two powers of the same base, okay? A is variable, stands for number. Not sure what number it is. Doesn't actually matter, but I'm going to multiply it 4 times. That's what this little 4 says, right? A, the same number. Then I'm going to multiply it times itself 3 times. Okay, so a to the 4th actually looks like this. That number times that number times that number times that number. Okay, good, right? This the base, that's the number that we're multiplying. The 4 is the exponent, that's the number of times we multiply it. Okay, so a to the 4th is here, a to the 3rd is there. All right, so when we do this, I can rewrite this as, right, there are 4 factors there are 3 factors there, so I can just sort of say, oh, well, you know what? I'm multiplying a, that's my base here, and I'm doing it 4 times, and then I'm doing it 3 times. Now notice I said and, which means I can take the exponents and add them, 4 plus 3, because altogether what I'm doing here is multiplying a 7 times. Okay? So there's a rule that they're suggesting, right? And this is the actual product of powers property. We're going to multiply powers with the same base, and then we're going to add their exponents, okay? Which is a great rule, but if you actually just understand what exponents are saying, and you understand how to multiply, you don't actually need to remember this rule. You just look at it and say, oh, well, yes, of course, this is multiplying 4 3 times, and multiplying 4 2 times means I'm multiplying 4 5 times. Okay, so let's take a look. We'll use an example. Lake Powell, the reservoir behind the Glen Canyon Dam in Arizona, can hold about 10 to the 12th cubic feet of water when it's full. There are about 10 times 10 to the 27th power water molecules in 1 cubic foot of water. These are just crazy big numbers. Okay, that's why we use exponents. This is 10, right? This is a 1 with 12 zeros. This is a 1 with 27 zeros. That's crazy. That's a lot of zeros. Okay? That's why we write the exponents. I don't want to write 27 zeros. Neither do you. So let's use the exponent, 27. Okay, they want to know how many water molecules can the reservoir hold. Okay, well, if 1 cubic foot has 10 to the 27th water molecules, well, then how many cubic feet of this? Right? If I have this many cubic feet, how many of these are there? So we're going to say the number of total water molecules is the number of cubic feet, right, multiplied the number of molecules, right? Because each cubic foot has that many water molecules. I have it this many times. Notice I said the word times. That's where this comes from. Okay? So we're going to get 10 to the 12th times 10 to the 27th. Well, this is 10 multiplied 12 times, and then I'm, right, and multiplied with 10 27 times. So altogether, I'm multiplying it 10 to the 39th power, right? 39 times I'm multiplying by 10. Okay? Hopefully this makes sense. You try this one, okay? You might struggle a little bit, but that doesn't matter. We'll give you the answer here in a second. So go ahead, pause the video, try this. Okay, so when you do something like this and you're looking at it, and if let's say you're not entirely sure where to start, just write everything without an exponent. So just make this, it's like this is just a giant multiplication problem. So write it out as a giant multiplication of all the individual parts. So let's multiply, here, I'll show you, this is what I would do instead, and then I'll show you what the book would do. I would just say, well, this is 3 times x times 5 times x times x times x times x times x. And then I would say, okay, let's see. How many x's am I multiplying, right? Here's 1 and here's 5. So altogether I'm multiplying x 1, 2, 3, 4, 5, 6 times. And then I'm going to multiply 3 times 5, and I know what 3 times 5 is. That's 15, so it's 15 times x to the 6th power. Let me show you another way how that would be done. Okay? The book does a little bit different. They rewrite it using the commutative property. Commutative property just means you can multiply in any order. So what they did is they took the constant terms, put them in front, right, the regular numbers, and then they took the variable terms and put them at the end. That's the variables here, x, okay? And then they're going to put them together, right? So then we're going to do the product power, right? They're showing, you know, we figured this rule out, so they're going to show that, and you get 3 times 5 times x to the 6th, right? This is the step I did as well. 3 times 5, 15. Okay? And there we have it. So, if you can multiply, and means you add, then we're going to look at this some more, and we're going to say, okay, well, what happens if I divide? So, we have the same idea. Oops, I clicked 1 too fast. All right, so I got a to the 5th over a squared, right? Some number to the raised to the 5th power divided by that same number raised to the 2nd power. So I'm going to go ahead and I'm going to look at this. I'm going to say, okay, I have 5 factors on the top and I have 2 factors on the bottom. And what I can do here is I can start canceling some of these out, right? Because it's a multiplication problem. I'm going to look at this and say, okay, a divided by a. Any number divided by itself is going to be equal to 1. And then I can do it again. A divided by a. Excuse me. Whoa, excuse me. Another number, a divided by itself, again, 1. So what's that going to do? Well, it's going to leave me with 3 factors of a, right? A times a, which then I can write as a to the 3rd. So really what you can say is, all right, I had 5 of these that I'm multiplying up here. I have 2 of these that are going to multiply here, okay? There are 2 from the bottom that will cancel out with 2 from the top. It leaves me with 3, so I've got a to the 3rd power. Okay, so here's the quotient. The quotient of powers property. When you are dividing with the same base, you just can subtract the exponents. Okay, and a can't be 0. It doesn't work when you do a is 0. Okay, numbers, they show you 6 to the 8th divided by 6 to the 5th. Well, there's 8 6's here and 5 6's there. So 5 will cancel from the top and the bottom, right? 5 will cancel out to make 1, which leaves me with 3. All right, go ahead, try this one. All right, hopefully you had paused the video and had a chance. If you didn't, pause the video now. All right, so I'm going to show you how I would do this. I would say the same way I did that other one. 3 times m times m times m times m times m multiplied by, this is 1, 2, 3, 4, 5. That's this part, right? Times m squared times m times m. All divided by 6 times m times m times m. And then I'm going to look to see what parts can I cancel. Simplify, really, right? So I'm looking at this and say, okay, this one cancels with that one. This one and this one make 1. This one and this one make 1. They cancel out. So 3 here and 3 here, when I divide them, come out to 1. Well, that's left with 1, 2, 3, 4. 4 m's in the numerator. So 4m to the 4th. And then I have 3 sixths, right? So I have 3 sixths. Well, I know that 3 over 6 is the same as 1 half, right? So this is equal to that. So then I can say, okay, well, this becomes 1, right? And this is 3 times 2. So the 3 cancels with that. And I'm left with 1 over 2. 1 m to the 4th over 2, right? And really what I did is 3 sixths becomes 1 half, right? See, 3 sixths becomes 1 half. Okay, that's one method. Let's take a look at what the book does it. Okay, they do the product power, right? So they add. So they're going to do 5 plus 7, or 5 plus 2 is 7. Okay, so then they get this. And then they're going to just go ahead and subtract. So they're going to do 7 minus 3 because of the quotient of powers property. And they're going to get 3m to the 4th. And then they're going to simplify. Okay, divide top and bottom by 3, and you're going to get m to the 4th over 2, which is the same thing I got, right? Notice I had a 1m. It's really the same thing, okay? How many m to the 4th are there? There's 1 of them. Okay, don't worry about doing those problems. There you go. Just bring these notes, and we'll do, like I said, we'll have an activity for class tomorrow. Okay.